Oh, hello. Welcome to Calculus Lesson 6. Today we are going to be covering functions and tons of stuff about functions. Remember that a function is a mapping of the domain onto the range. And in simpler terms, it's for every input, there is one and only one output. So if we have an input to our function, we get an output. If we have one input to our function and we have multiple outputs for that same input, then it is not a function. Simple as that. Now, they're going to have you do some things with functions. The first one is plugging in random things. So let's say f of x is x squared plus 5. Remember, x is the input, that's the number going in. F of x is the output, the number coming out. So if I ask what is f of negative 2, I'm simply going to replace every x with negative 2. So that means in parentheses, negative 2 squared plus 5. In algebra, they would have written a question like this and then written x equals negative 2. We're doing the exact same thing. You're simply plugging in. So from there, negative 2 squared is 4 plus 5 is 9. I hope I got that one correct. I did. All right, next we have f of x plus 2. Now, it bothers a lot of students that I'm plugging in something with x into x. That's fine. If you want to call this star, and you're plugging in x plus 2 every time you see star, that's fine too. So we're going to do the same process. In parentheses, we're going to plug in x plus 2 squared plus 5. So that's x squared plus 4x plus 4 plus 5. That looks like x squared plus 4x plus 9. If you didn't follow that, go back, watch it again. This is so important. The last one, and this is actually going to be basically fundamental to our study of calculus, is we are going to plug in to f of x is x squared plus 5. We're going to plug in f of x plus delta x. Think of delta x as one thing. It literally means change in x. So that's one quantity. It's not triangle times x. It's delta x. It's one thing. So regardless of what they give me, I'm going to plug that in for x in parentheses. So this equals x squared plus 2x delta x plus delta x squared plus 5. Gross? Yeah. But that's what we have. Okay, there are some questions in there asking you to use a graphing calculator to estimate the value. What you're going to do is you'll plug in that function. So if we are estimating f of pi, you would plug in this function to y1 equals x squared plus 5. And then the easiest way to do it is to hit the trace button and plug in pi and press enter. That will give you the value of the function at pi. The more official way to do it would be to go into the calculate menu and click value. But this way works perfectly fine. Alrighty. Sometimes if you try and plug in numbers that are outside of your window, then you have an issue there. Now, let's talk about what is a function and what isn't a function. I already gave you the definition over here. In order to have a function, for every input, there must be one and only one output. We use something called the vertical line test to test this. So let's look at these functions. Is that a function? Well, what I'm going to do is I'm going to take a vertical line and sweep across. If it only touches my function at one place at any given time, then it's a function. But here, this guy fails the vertical line test and is not a function because somewhere along the way, it touches my vertical line twice. I dropped that. Okay. They're also going to give you sets of numbers or ordered pairs and ask you if those are functions. So let's do an example. Let's do one like this. So these are ordered pairs or points that would be on your function. Is this a function? Well, I'm going to look, and again, for every input, there is one and only one output. So I'm going to look for repeated x values. So I have 4, and I have a 4 here. If they go to the same output, I'm good. If they go to a different output, it's not a function. So both 4s go to 3. There's only one output for the input 4. So this is good. There's no other 2s going in, and there's no other 3s. So yes. This is a function. However, if it was 4, 3, 2, 2, 4, negative 3, 3, 3, this is not a function because 4 goes to 3 and 4 goes to negative 3. And that would mean that it has more than one output for the input 4. Alrighty. Next, we are going to talk about domain and range. So, let's suppose they give you a function. Actually, let's start off with some friendly functions. So, a good function to start with is y equals x. Okay? I can plug in any number I want to y equals x, and I'm fine. And I will get that exact same number out. So when I'm talking about domain, I'm going to say that x is in the real numbers, and there is no restriction. So I have nothing there. On the range, y, that's the number coming out, is in the real numbers, and there's also no restriction. But when I get to more difficult functions, like the square root of x, there are some restrictions. Why? Because I cannot plug in a negative number. So when I write my domain, x is in the real numbers, but x must be greater than or equal to 0. So you'll write the condition afterwards. Now, what kind of numbers do we get out of the square root? And this is something that you should just know off the top of your head. If not, you can graph it, and oftentimes that'll help you. The range is also only non-zero numbers. So I can plug in 0, and if I plug in like 2, 4, 2 is bad, 4, 9, 16, I get positive numbers out, right? I'm never going to get a negative number out of those. Other weird functions that you need to work with, 1 over x. This one's strange. If you graph it, you'll see that it's strange. The domain is real numbers, but x cannot equal 0. And your range is real numbers, but y will not equal 0. There's no way to get 0 out of this, but you can get every other number in the real numbers out of that. Now, we can also combine these and make it more ugly. And that's going to be where we end our lesson today. So let's find the domain and range, or the inputs and outputs of this function. We have f of x equals the square root of x over x minus 2. So we know from over here, we'll zoom out a little bit, that the square root of x has this domain and range. But we also know that x minus 2 has an issue, probably when the denominator is equal to 0. So what I like to do when I'm doing these problems is I will write out the two domains that make sense. So in this case, from the top, x must be greater than or equal to 0. Here, instead of x like I had here, I now have x minus 2. So I'm going to write x minus 2 cannot equal 0. So you just replace the x here with whatever is under the denominator, or if I had something ugly in the square root, I would replace that here. Now, let's solve these two. X is greater than 0 and x cannot equal 2. So my domain is going to be that x is in the real numbers and x must greater than or equal to 0, but cannot equal 2. What about my range? Well, I know I can only get positive numbers or 0 out of this, but I can get a whole bunch of numbers out of this, right? And so, in fact, our range is the real numbers. But you would really only know that by graphing it. So sometimes you just have to graph them and then look at the response. And that, my friends, is problem set 6.